weapon systems operational.
Hello, engineering fam. Welcome to another episode of Get on Code. So these functions are going to become a lot more important and used a lot more consistently as we move through the data science course. Before we get started, go ahead and drop a like, share, subscribe. Now, with that being said, let's go ahead and get started. Okay, so let's get into our Python storage methods. These are the native storage methods that are going to become more and more popular or more and more use as we go on with this data science portion of Get on Code. So as you can see on the screen, you see four different methods. You see a list, or I should say functions, list, a tuple, a set, and a dictionary. And we're going to break each one of those down. Now, let's start off with the list. The list, of course, is a collection of objects or items of any data type. So you can have anything in there. As you can see, I have a string, I have an integer, I have a conditional statement, and another string. Now, right now, the good thing about a list is that a list is mutable. Mutable meaning that it can be changed after it's created. So as you can see right now, we have it at index 0, right? Now, let's print out the whole list, and it will print all the objects in the list. Okay, it says A, 2, true, and B. Now, if we want to index it, as we all know, or if you don't, I'm going to let you know, every index for a list starts with the 0 place. The 0 place is the first place in the list. So for this case, it will be an A. So it starts 0, 1, 2, and the B is in the 3 spot. So there's 4 different spots, but it does not start from 1, it starts from 0. Right? So let's print the 0 element. You can see it's an A. Now if I were to say let's print the third element, it's actually going to print out B because that is the last one out there. Now if I go outside that range and let's say I do a 4, it's going to give us an error because the list is the index outside of the range. The 4 spot will be if I added something here after B, right? So that's a list. Next we have our tuple, and a tuple is a collection of objects or items of any data type. Thing about that's different from the tuple and the list is that a tuple is immutable, which means it cannot be changed. However, it does still support indexing. So same thing like a list, 0, the A is going to come out. Let's run that. And if we do 3, it's going to be B again. So the difference between the list and a tuple really is that a list can be changed after it's created, i.e. edited, and a tuple cannot. Now let's move on to a set. Now, the set is interesting because a set is like a mathematical set function. All right. So a Python set does not hold duplicate values and automatically arranges in ascending order. So this is what you would do if you wanted to have like a record base. Okay. And it does not support indexing. So I can try to index it like I did with a list or a tuple, and it's going to give me an error. There you go. So a list is what it is when it's created. 1, 2, 3, 4. Now, finally, my favorite, we have a dictionary. Now, dictionaries work very similar to real-world dictionaries. What they do is they use a key value pair, and like the real-world dictionary, each word has a definition. So what do I mean? All right, so you can see that the dictionary, like the set, is separated with curly brackets. Yes? But with the dictionary, you can actually create your own indexes. It doesn't just start with 0 like a list or a tuple. It starts with whatever index you want. So in this one, I created 1, 2, and 3. That's the index. The key is 1. The value is January. The key is 2. The value is 100,000. These are strings. The key is 3. The value is Florida. So let's take a look at it. Let's see what our first index value is. So number 1, we get January. Simple enough. Number 2, we get 100,000. Number 3, we get Florida. Now let's say we want to start with a 0 like we did in our list or our tuple. Because remember, the list and the tuple start from 0. 0.
Weapons fire detected. Weapons fire detected.
So let's put 0 in our dictionary. Oops, doesn't work. I have not created a 0 key. Let's go back to that. 1. Now, let's say I did want to create a 0 key. I would simply just add another key value pair, call it 0, and I would say elevated engineering. Now, because I created that, it's now going to print up elevated engineering. And that's the beauty of dictionaries. With dictionaries, you can create your own value and your own key, and you can edit it as much as you want. And that's why I love dictionaries. So these are going to become much more important as we move on in this data science portion of Get On Code. Okay, so that's it for Python data functions. As we move through this data science course, we'll start performing more advanced data analyses using the native Python data functions. We'll use them with NumPy, Pandas, and other statistical and data visualization tools for Python. So stay tuned for the next chapter in this Get On Code series about Python and data science. Now, as usual, go make something cool. All right, going to be going over a few different topics, including introduction to NumPy, indexing an array, slicing an array, and of course, performing operations on an array. So, get ready. Let's go. We're going to import our Numpy function. Normally, it's just for easier sake. You're going to see it imported as MP. So basically, we run the import statement, import Numpy as MP, as we're going to do right here. So to start off, we're going to do a few different things. I want to introduce you to what Numpy is. Then we're going to run a couple of operations. We're going to do some indexing of an array, slicing of an array, and we're going to do some operations on the NumPy array. The thing about NumPy that's different from the built-in Python functions is it's specifically designed to extend Python's mathematical and statistical analysis, and it is more easier to use and manipulate arrays, which is going to be holding our data information. So we're going to be working with basically, I want to be doing some operations on a BMI, which is a body mass index, for better interpretation of the results. It's a little easier. Basically, the body mass index is the weight divided by the height of a person. right? So, but before we get to that, let's start with just our NumPy array. So typically, we have a list, and I went over a list in the previous videos about Python functions. But for this example, we're just going to create a list of height and weight. So let's go ahead and do that first. So let's start with our weight first, right? So what we want to do is we want to convert our list to a NumPy array. See, normally we create a list, let's say 100, so it weighs 100, 110, 120, 30, 40, and 150, right? So that's 6 different values, right? When we want to see what type of function this actually is, Python will tell us, right? It's a tuple right now, right? We put it in brackets, becomes a list, okay? And that's good for just storing information, but that's not what we want to do. We want to actually convert it to an array for statistical analysis. So it's as simple as numpy dot array, open parentheses, close parentheses, and oh, got the wrong name. Not numpy, np. Right, so now we want to see what this is. This is going to be our numpy, our first numpy array, right? And it says numpy nd array. Okay, cool. So first, now that we got that out the way, we have our first numpy array. Let's go ahead and set up our height, right? So our height is going to be something simple. I like to do inches because, of course, I'm American. So we're going to do 66 inches, 67 inches, 68 inches, 69 inches, 70 inches, 71 inches, and that is 1, 2, 3, 4, 5, 6. And now we have our height and our weight, right? But before we start getting into slicing and dicing our array, I want to show you what BMI is. So basically what I'm going to do right now is I'm going to tell Python / NumPy that I want you to divide each element in weight divided by each element in height. So it will be 100 divided by 66, 110 divided by 67, 120 divided by 68, 130 divided by 69, 140 divided by 70, 150 divided by 71. And I'm not going to do the floor. The floor would basically round it down. We're going to get the true BMI, right? So let's run that. Nothing appeared. So now let's go ahead and actually print out our BMI. We're going to get a bunch of decimal type values, right? So we basically just created an array with all of our BMIs, right? So body mass index, 1.5.5, 1.641, etc., 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 right? So this is going to be our BMI. We're going to be referring back to this throughout this entire video.
Weapons fire detected. Weapons fire detected.
Now that we have our BMI, we can actually see that our BMI is actually a NumPy array as well by just simply typing type and running it. It's a NumPy array. So now that we have our BMI array, we want to do a little indexing. So let's say we just want to select the first element in our BMI, right? So because our first element, remember, when dealing with arrays, the first element always starts with 0, not 1. So if we deal with our BMI first element, it gives us this 1.15, all the way, right? This element right here. Okay, and if we wanted the second element, it would be 1, not 2. Okay, now let's say we wanted a range of elements. So we wanted just the first element, the second element, and the third element. We would have to simply just 0, colon, and because we want the first 3 elements, we have to go 0, 1, 2, all the way to 3. It's not going to include the third element or the third number in this array, which will be 0, 1, 2, 3, which will actually be the fourth element. It's only going to include 0, 1, and 2. Quick. Okay, so here's our elements: 1.515, 1.641, and 1.764. Okay, so now that we have our index sliced up in this 0 to 3 operation right here, just know the difference. Okay, so when you're trying to set an index for an array, our index 0 right now is going to be the first element. So let's go ahead and get that up again. This is our first element, 1.51515, but when we're slicing, we're taking a segment or piece of the array and actually just looking at those specific sets. And this is 0, 1, 2. We don't want the 3. Again, just repeat. So now that we have some of our indexing and our slicing out the way, we want to perform some basic operations, right? So the first operation we're going to perform is we're going to be doing a conditional statement, just a less than or greater than. So in this case, since most of our values are under 2, let's just say, let me get all the values under 2 for the first 3 elements, right? So that's going to just tell us the true or false. Every single element, 1, 2, and 3, 1, 2, and 3 are all going to be true because they are all less than 2. Now, just for example, if we just want every element that's less than 2, as you can see, the last 2 are false, and that's 2.112, and actually it's even 2.0, so that's the 140 divided by the 70. Okay, so that's just a simple conditional statement. But what if we want to do something a little more complicated? Let's say we want to multiply everything in our BMI array by 2. Right? So it multiplies everything by 2 in our array, or something. Maybe we want to send it to the power of 2. Right? We want to square it. That's essentially what the 2 wildcard statements is. 1 is just multiplying it by 2, and 2 is in this case we're squaring it because we're taking it to the power of 2, but we're just squaring everything in our element, or everything in our array by 2, right? So we're squaring it. So those are just some simple operations and some simple slicing and indexing of a NumPy array. You got the answer to the quiz correct. Yes, NumPy is used to perform statistical analysis on data sets using Python. Not too bad, right? That's it for this episode of Get on Code. Tune in for more coding tutorials and subsequent chapters. in our Python for Data Science series. Now, as usual, go make something cool. There's a few different things that we're going to be doing. So, continuing on from last video, we have our basic BMIs. And you can see we perform some basic operations on our BMI array list. For this, we're going to continue some arithmetic operations and be a little more complicated. And this will also add on to later when we start doing our pandas data frame. So the first thing we want to do is we have our BMI array, right? So let's just make sure that our BMI array is a BMI array. We can do that just by simply doing type and seeing if it is. So it is a Numpy array. You can see. All right. So there's a few different operations that I'm going to do. The first operation I really want to do is something easy like removing all the odd numbers. Since we have a couple different, or three different arrays, the weight array, the height array, and the BMI array, I'm just going to try it on the weight array first and see if we can kind of just move with that. So let's go with odd, create the variable odd, then we are going to have our weight array, and we want to do a modulus. Modulus is going to give us a remainder, right? So when we divide every element in our array by 2, we want to have one number, and that fills the statement of defining a odd number. That will be 2k plus 1. All right. So if you ever want to know just how you prove odd number is an odd number, you write a statement, and you would say that if the statement is 2k plus 1, then it's odd. If it's just 2k, because 2 multiplied by any number is going to be an even number. That's how you will prove if it's odd or even. Right? So now we're going to actually call our array weight, and we want to call the actual function that we just created odd, and we want it to be equal to -2, right? Then we want to call it. Let's try that. Okay, so as you can see, there's no odd numbers in weight. Only even numbers, 100, 110, 120, 130, 140, 150. Now, if we change this up to our height, because I know height has at least a few different even numbers, or odd numbers, I should say. Simply change it from height, equivalent to 1, and then we are going to call our height again. Now, as you can see, our array actually removed a couple of different elements, and it replaced every element with -2 that is odd. So you look at our original height array, we have 67, which is odd. 67 is replaced by -2. And we have 69, which is odd, which is replaced by -2, and 71, which is odd, that's replaced by -2. So that's just a simple operation to actually remove the odd numbers and replace it by -2. Now you could actually replace it with anything. If you want to replace it with -1, you can do that, and it's just going to be -1. I'm sorry, -3 in each one. We would have to reinitialize our weight variable again, and we can replace everything with it was -2 before, we'll replace it with -1. Right now replaces every element with -1 that's odd. Okay, so that's just a simple way of just removing elements. Of course, these are all things that are going to become more important later on. The next thing I want to do is simply to just calculate the entire sum of one column in our array. So for this, I'm going to actually go for BMI this time. And it's because NumPy has a bunch of different functions built in, you can actually calculate the sum of pretty much everything in here. So let's go BMI is the array, and we're going to actually do with access to equal 1, which is actually our column access, or yes, our column access.
Weapons fire detected. Weapons fire detected.
I made a mistake. Actually, when you do it at 1, it's because BMI only has one column. You actually have to set it to 0 and not 1, because 1 will be the second. And there we go. So let's do that, and then let's print that out. Matter of fact, let's change the name of that from BMI sum, so we can tell the difference. All right, so everything added together is 10.918, right? That's basically everything in our BMI array added together. You can do the math yourself, and then that's again, when you're trying to sum up a column, that's going to save you a lot of time, and NumPy has all this stuff. Now we're going to get to the meat of this section of the video, because we're going to get into doing element-wise remainder, and we want to divide that by, let's just say, 4, and we are also going to reshape the array, which is we're going to be using a lot more going forward. So the first thing we're going to do is, we already have our arrays set for. I want to convert our list to an actual array. So here's what we're gonna do. We're gonna say li, and we're gonna say np dot asarray, and we're going to take our BMI array, and we're going to reshape it. Now, why are we going to reshape it? We're going to reshape it to give us actually more rows and more columns. But we have to be careful. When we reshape our array needs to actually be be able to be divided evenly by the same number of elements we have in our array. So we have in our array 1, 2, 3, 4, 5, 6 elements. 1, 2, 3, 4, 5, 6 elements. So our array needs to be a multiple of 6. So we can say, let's say it is 2. We want 3 rows and 2 columns. All right. Now it says array shape is into 1. Oh, so it's actually needs to be, again, rerun it because our BMI value was changed, which is why we need to actually consistently and make our BMI variable easy to read when we redo it. So BMI sum, and now, okay, so we're gonna reshape our array 3 by 2. So that's 3 rows and 2 columns, right? So now, for the next one, we're going to get the element-wise remainder. Not the modulus, but the element-wise remainder. So we're going to do true divide. So that way we get our NumPy is going to round our elements down. We're going to say 1, and we're going to divide everything by 4. Right? So that's pretty much it. Now, even if you wanted to say, let's say we wanted to have 2 rows and 3 columns, it will be, it's very similar. It just has to be a multiple of 6. And the elements need to be a factor of 6. I'm sorry. So you see it's 2 times 3 is 6, or 3 times 2 is 6. So we divide everything by 4. That's going to give us some crazy numbers, but you get the kind of gist. That is the sum of doing the arithmetic operations. Next, we are going to learn about concatenation of an array. Or, I'm sorry, just concatenation for right now. We'll say concatenation of array for the next videos when we start doing panda stuff. Right? So, concatenating an array is basically, you are basically, in this sense, you are combining 2 different arrays together. And you're choosing how to actually display them. Right? So, for this, we're going to be using the function concatenate. NumPy already has it built in. Concatenate. Then we're going to say we're going to create another array, and this time we're going to use weight and height. Right? So that basically just brings everything from weight and height together, and in this case, by default, it just puts them in the order in which they are placed. Okay, and that's fine. You can also do height and BMI, and it does the same thing. So this, all concatenate really does is, as long as the 2 arrays are the same size, meaning they have the same number of elements, I can pretty much bring them together quite easily for display. This is really gonna get more important as we get along in this course. Who got the answer right on the quiz? In this chapter of the Get on Code NumPy tutorial, we learn about performing arithmetic operations on a NumPy array, and of course, we learn how to concatenate matrix arrays. Now, stay tuned for the next chapter in the Python for Data Science tutorial by subscribing to my channel, 1, and clicking the notification bell for more updates. And, of course, as usual, go make something cool. Now that we learn about concatenation of array, we're going to go into splitting of an array. And that's basically, we're going to be breaking up the array, and there's various ways to do it. We're only going to focus on a few. But first, we want to start as you can see, I created array 1 right here, which is just a range of values from 0 through 9, right? So when splitting an array, we basically have different choices of how to do it. So the first, we'll just look at the basic way of splitting an array, and that's just by using split. So what we're going to do is we're going to split our array into 2 different arrays, right? So pretty easy. Numpy has it's built in. So let's split it. Let's go ahead and designate our array. Matter of fact, let me change that to lowercase because I hate uppercase. Okay, we're gonna change it to array 1, and we're going to split it into 2 different arrays just by simply doing 2. Now, as you can see, 2 different arrays are created, 0 through 4 and 5 through 9, right? And the reason it shows up in 2 different arrays very easily is because we have 10 different digits, right? So it splits it pretty evenly. Okay, so next, now that we have splitting our array, you can split your array in different ways. For example, you can choose the index that you want to split it on. So just really quick, let's change this from 1 to X, and let's change that to 1 to X, because I want to distinguish it to being like, you know, on the x-axis and the y-axis. So we're going to split our array. We're going to create a new array, and we're going to split it on whichever index we choose. So let's say, for example, we want to split it on the 3rd and the 7th index. So let's go and run that really quick. Too many indices with 2 were indexed. So, oh, that's why. forgot to separate it. All right. So let's just print that out really quick. Array Y. Right. So as you can see, it basically puts the 3 and the 7 into its own separate array, and 0 through 9 is in the first array. Okay. That creates 2 different arrays, but that's not necessarily what we want to do. We actually want to split it instead, and this will actually create different arrays based on the indices, right? So now you see we have 0, 1, 2, and the second array is 3, 4, 5, 6, and the third array is 7, 8, 9. So that's pretty much how we go about splitting on indices of our array. We've seen how it works to kind of split it into 2 different subarrays. Basically, we're going to next we'll do splitting it into 3 different subarrays. So just for example, we can use our BMI that we've been working on up to this point, and we could just go ahead and split that into 3 different subarrays, right? So as you can see, we have 3 different subarrays. what's basically happening is we split the array into 3 subarrays, and it returns basically whatever our numerator, or however many there is. I think we have 1, 2, 3, 4, 5, 6. It'd be 6 divided by 3, and it's basically because we have 6 different values. It goes into it. It creates 3 different arrays with 2 elements in each one. So that's cool for when it's, you know, does it evenly. Matter of fact, let me go ahead and comment that. Subarrays, and we're going to split the indices on the 3 and 7. Right? Now we're going to split our BMI array into 3 subarrays. Essentially, it returns 6 modulus 3 is going to equal well, 0, because there's no remainder. There's no remainder. BMI array is split into 3 arrays with 2 elements in each array. Okay? And we can even try it with our actual array that we created. So let's just say np dot split array x. We're gonna split it into 3 different arrays, subarrays. Oops. Because it's an equal division, it's not gonna participate right. And if we do it like that, okay, yeah, okay. Oh, sorry. We gotta use array split because we're actually splitting it based on the array. Change that to 3. All right, so that's the difference. So there's a couple of different ways because of the fact that 3 doesn't divide by, or 10 doesn't divide by 3 evenly, because you would still have a remainder of 1. It splits it into 3 different arrays, but as you can see, the first subarray has 4 elements, the second subarray has 3 elements, and the final subarray, the third one, has 3 elements as well. Okay, so now we're gonna explore using vsplit. Now, we have an array that has 10 different elements, but right now it looks a little weird. So let's just go ahead and reshape that. Let's go reshape array x dot reshape. It has 10 elements, so we want to try 2 rows and 5 columns. Let's see what that looks like. Alright, so it's just lined up into 2 different rows that are stacked on top of each other. Right? But let's say that we want to actually implement the vsplit. The vsplit is essentially splits array into vertically stacked arrays as opposed to just having them sitting like this. So all right, so let's go let's use mp.v split, and we're gonna go how are we gonna split this up? How about array square b? I'm gonna split into two different subarrays, right? Take that off. P.B split. Here we go. All right, now you can see it's a little neater. Right now, it's a little bit easier to read as opposed to even if we go ahead and do a H split, which is going to actually split it horizontally. Splits array horizontal. So let's go array H equals array X. Let's go ahead and, I mean, we really don't need to reshape it. Just wanted to p dot H split to yeah. All right. So as you can see, what I did up here is I actually kind of did the inverse of the V split, because the V split should just be it would be stacked on top of each other, but because I did the reshape and I reshaped it into 2 by 5, it did the inverse, which would be a horizontal split. This is interesting. Yep, equal division.
Weapons fire detected. Weapons fire detected.
Using the V split, we're gonna go straight into the H split. But for this one, we're gonna create a whole new series of integers for our array. So let's go array H equals mp dot a range. Let's just say 20. And then we want to reshape that array to have 4 rows and 5 columns. Okay, so let's see what that looks like. Alright, so you can see we have 4 different rows, 5 different columns, but I want to actually split that horizontally. So, and I believe it's horizontally based on a column, so it's column-wise split. So what we're going to do is just simply mp.h split, and we want array h, and because we need to have an equal division, it needs to be 4. So we're gonna split into 4 different subarrays. Now that we have our array H and it's reshaped into 4 different columns to 5 different rows, let's see if we can go ahead and use H split to split it up into what's going to have to be dividable by 20. So it's already in 4 different rows, so we want to actually split it into 5 different columns. So let's go 5. All right. So you can see there are now 5 different subarrays for a range of 20. And this is, of course, when you're arranging your data and you are pre-processing your data, when you're starting to get your data ready to be trained, and you're splitting your data into training, testing, and validation sets, you're gonna need to learn how to actually reshape and split your data based on what the actual requirements are. Eventually, later on, we're going to get into different neural networks and different dimensions for different types of data. For example, an image, a JPEG image, has 3 different dimensions of data. It is red, the blue, and the green pixel dimensions. That's going to be much later on in this course. And that's it for Numpy.